This document was created by Leonardo Diaz, Shakir Shahid, and Jad Wahab. We are dedicated to producing efficient software and satisfying our customers. In this document, you will find our ideas and blueprints for the software code. This section provides an overview of the entire requirement document. This document describes all data, functional, and behavioral requirements for software. So goals and objectives. Our goal is to enable homeowners to design and test their home alarm systems using a touchscreen mobile device. Our software objectives is to allow our user to set up a virtual room where they can choose from a selection of items such as doors, windows, sensors, and furniture from an inventory, and our users will be able to place them in the room. Also, our objective is to allow our users to modify the objects and evaluate the coverage of the sensor network within the room. We will allow the user to save a copy of the virtual room so that they can make modifications to it whenever they want. So the statement of the scope is a way in which our users can add designs, can create virtual rooms, can choose from a selection of items, and can save a copy of the virtual room. Pretty simple stuff. In the software context, our mobile app will expand to users all over the world. Our intent is to help turn our users' imagination into reality. Users will be able to decide what kind of room they want by using our software. If our user is thinking about buying a couch, but they don't really know how it's going to look in the room, they can use our program to picture that couch in the room. Some major constraints. Time, funding. It is pretty expensive to develop and produce software for the entire world. So there will be two levels of users, administrators and the general public, which are the users. The users will be able to create, view, save, and share their virtual room if they want to. Uh, the user stories, they define use cases for the software. Special usage considerations. So some special requirements is allocation of memory and deallocation of memory. And data model and description. Here I have the user ID, username, user save, room ID, and virtual room. And some data objects here is again user ID, username, user save, room ID, virtual room, items, windows, and sensors. Here I have my CRC cards with the class being the virtual room, the abilities being able to select items, add designs, add windows, add sensors. Here I have the UML class model to really picture, everything easier. You have the user, the data, it points to the virtual room, and the virtual room expands to items, designs, sensors, and windows. Items has furniture, walls, and I will include more later on, but to make this more simple, I just included furniture and walls. For sensors, cameras, obviously if you want a security system, you want cameras in your room. And functional model description. The functional model is a representation of the major software functions and their interactions. Use case diagrams show the actors and their interactions with the system. Sequence diagrams show the order in which messages are exchanged between the actors and the system, while communication diagrams show the flow of messages between them. And just quickly, skimming through all of these, let's head on to the diagrams, which I feel is important before my time runs out. Here, I'll begin with the use case diagrams, the control flow. So basically, the user wants to make a virtual room. So before the user does so, the user will go through the steps of creating the virtual room. Here, you have add items, add design, add furniture, add window, all that good stuff. And here we have the sequence diagram. So basically, the user will first open our app on their mobile device. The user will be greeted in the main menu, and the app will display its features. And one of the features include creating a room. If the user chooses to create a room, the room will successfully create itself and will give the user a variety of items to choose from. Those items can be anything. A room can have like a door, carpet, ceiling. It can really be anything. You know, once the items are chosen, the room will be updated and displayed to the user. The program will continue to loop to give the user a chance to modify their room in case they don't like it. So the condition breaks once the user saves the room. And for the communication diagrams, the user will first log into their account. The second step is for the user to create a room. The third step is to advise the system what items can be added to the user's favorites list. If the user chooses, for example, a door or a window, they can change it. They can change its dimensions, for example. If the user likes their modified room, then they can have the option to save it. And for the behavioral model description, the virtual room software is initialized when the user accesses the system. This involves verifying user certificates, setting up the virtual environment, and initializing the necessary hardware and software features. And going down here, we have states. If the user were to input an invalid password, then it will prompt the user for re-entry. And in my state transition diagram here, I have how the system reacts to an invalid password. In the diagram, the system first reads the password and then, it tries to verify it. If the password is incorrect, then the system will allow the user to input the password for a number of times, for example, let's say 4 times. But if the user continues to input the wrong password more than 4 times, then it will lock itself and there will be a timer to that lock. But if the password is correct, then it will be successful and the user will be able to create their virtual room. And here I'll let Jad take over for the remaining of the chapters.
Hello, thank you, Leo. Jad Wahab here. So, continuing to the activity diagram, which models the flow from one activity to another, we have the user enter their user ID and password. If invalid, it prompts for re-entry, or the user can reset their password/ID. If successfully entered, the user can create a room, enter the dimensions, and the options and items are limited because of the following conditions of the user cases. So we just limited it down to window and door object. So click and drag the window or whatever item. Input in place, updates the room and coverage of the sensor network, displays updated virtual room to the user, and exits the function. Carrying on. We have restrictions, limitations, and constraints. So there are several restrictions, limitations, and constraints that can impact the specification, design, or implementation of the software, some of which were mentioned earlier on. So the compatibility and performance of the software must be unique and must be designed to work with a wide range of screens. We have accessibility and security as part of those limitations, constraints. So the software must comply with relevant legal, data protection, privacy laws. The software must also be user-friendly and easy to use. For the validation criteria, here we have the approach to software validation. Each feature/component of the software should be tested individually and make sure that it performs correctly. For example, the create room use case can be tested to ensure that the room is created with the correct dimensions, while the place a window use case can also be tested and added to the wall in the correct position and dimensions. We have the classes of tests. So we have different types of testing. What is expected from the software response? Here are the expected results. As for the performance bounds, there are special performance requirements for the home alarm system design software that can include the speed. So any actions such as adding or moving objects in the virtual room can be carried out quickly to avoid frustration of the user, such as dragging. Responsiveness time should be less than 1 second, so there shouldn't be any lag or delay. Memory usage, the memory usage of an application should not exceed 500 megabytes, for example, while designing a virtual room. So storage is important to keep in mind. For appendices, we have Appendix 1, where you have the selection of items such as doors, windows, sensors, cameras, furniture. Appendix 2, modifying objects. So allows the user to modify objects in the room when it comes to dimensions or placement. Appendix 3, evaluating sensor coverage. So placing sensors, modifying the position of the sensors, checking the coverage of the sensors. And Appendix 4, saving and loading rooms. Users should be able to save a copy of a virtual room so that they can make modifications to it whenever they want, add or remove items from their virtual room anytime. Here we have the system traceability matrix following the 4 basic requirements as stated before. User can add designs, can add a virtual room, can choose from a selection of items, and can save a copy of the virtual room. We make sure that each use case is filled in for each requirement for the 3 user cases. So the table above shows how the software requirements are traced back to the user cases. It allows us to keep track of which requirements are met by which use cases. So this matrix helps that all requirements are met by at least one use case. So for example, a way in which our users can create a virtual room, that's met by use case 1. Use case 2, for example, is met by the ability to choose from a selection from the items from the inventory. And so for product strategies, possible product strategy for this home alarms system design would be to provide a user-friendly interface for home owners to easily create and modify the virtual room designs. So one strategy can involve using augmented reality, VR, or other immersive technologies to enhance the user experience and make it feel more interactive and engaging. Analysis metrics to be used. We have user satisfaction to take into account. So measure through surveys, feedback, reviews, based on the software's functionality and usability. The time spent on tasks should be measured. So all these type of analysis metrics are used to track the development process as well as possible modifications for improvements that can excel the user experience and meet the demands of the target audience. Overall, we created a comprehensive requirements analysis to set up the purpose in creating a user-friendly tool in which allows homeowners to set up a virtual room, add items, and save the room. Thank you for your time. Goodbye.